Good morning, everyone. So, in the last class, we had studied about the introduction of arithmetic progression. That is, we had discussed what do you mean by arithmetic progression and what is the generalized form of arithmetic progression, and also we had discussed about the types of arithmetic progression, that is, the finite arithmetic progression and the infinite arithmetic progression. So before going to the next topic, let me revise this topic as it has been too long. So coming to the definition of arithmetic progression. So basically, as you know, arithmetic is nothing but the study of numbers, and progression is nothing but series or a numbers in sequence or order. So basically, an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. So it is an sequence, that is an arrangement of numbers in which each term is obtained by adding a fixed number to the preceding term. Preceding term is nothing but the previous term except the first term. So some of the examples for arithmetic progression are, they have been given that 1, 2, 3 for the set of natural numbers, and also we can say even numbers is also an arithmetic progression, as well as a set of odd numbers is also a example for arithmetic progression. So this fixed number that we add to the preceding term except the first term is known as the common difference. So as we know that we add a particular value to the preceding term, that is the previous term, to get the value of the next term. So this fixed number is known as the common difference. And always remember that the common difference can be positive, it can also be negative, as well as it can also be equals to 0. And after that we started with the generalization of arithmetic progression, that is, so let us denote the first term of an arithmetic progression by a1, second term by a2, third term by a3, and so on, and the nth term by an. And let d denote the common difference. Then the arithmetic progression is given by a1, a2, a3, and so on up to an. Right? And we know that the common difference is given by subtracting the second term from the first term, and so on. Third term minus second term, fourth term minus third term, and so on. Right? So we get the expression for the common difference, which is nothing but t is equals to an plus 1 minus an. So in the form 1, that is in the equation 1, we are not able to denote the common difference, which is also an integral part of the arithmetic progression. That is why we generalize it by taking a1 is equals to a2 is equals to a plus d, a3 equals to a plus 2d, a4 equals to a plus 3d, and so on. Then the equation 1 becomes a plus d, a plus 2d, a plus 3d, and so on. So where a is the first term of the AP and d is the common difference. So this is now called as the generalized form of an arithmetic progression. And after that we studied about the types of arithmetic progression, that is finite arithmetic progression and infinite arithmetic progression. So in an finite arithmetic progression means it will be having finite number of terms, and infinite arithmetic progression means it will be having infinite number of terms. So examples for finite arithmetic progression are the set of numbers from 1 to 10, and you can also take all even integers less than 100 or 1000. They are all examples for finite arithmetic progression, as they have an end point, that is they have a last term. And examples for infinite arithmetic progression is the set of all real numbers. So the real numbers does not end, they continue up to infinity, and that does not have a finite end, and hence we take real numbers as an example for infinite arithmetic progression. And lastly, we studied about the necessary conditions to identify an arithmetic progression. That is, what are the minimum requirements that we have to know to identify the given series is an arithmetic progression or not. So there are two important conditions. That is, the first one is knowing the first term, that is the first term of the arithmetic progression, which is the value of a, and after that we should know the common difference. What is the common difference of the given arithmetic progression, and hence knowing these two terms will help us to identify the given arithmetic progression, whether it is a arithmetic progression or not. So with the help of these two conditions, we will be identifying the arithmetic progression. So for example, if the first term of an AP is 8 and the common difference is 2, then AP could be written as, so just writing the generalized form, that is a plus 2d, a plus 2d, a plus 3d, and so on. So we know the first term of an AP, that is the value of a, which is equals to 8, and then you should go on adding the common difference, which is 2, 8 plus 2, then 8 plus 2 into 2, then 8 plus 3 into 2, and so on. So you'll be having the series, that is 8, 10, 12, 14, 16, and so on. So these are the necessary conditions to identify an arithmetic progression. So I hope the revision of the previous class is clear. So if you still have any queries, you can contact me. So now we shall begin with this today's class. So in today's class, we will be solving some of the simple problems on the arithmetic progression. That is, whatever we have studied so far, we will be using that and solving the problems. So the question is, in which of the following situation does the list of numbers involved make an arithmetic progression, and why? So they will be giving you a set of situations and you have to write down the data in mathematical form and check whether it forms an arithmetic progression, and if it does not form an arithmetic progression, you have to give reason, and if it forms an arithmetic progression, then also you have to give what is the reason. So the first question is, the taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for the each additional kilometer. So they have given the taxi fare for each kilometer, that is for the first kilometer it is rupees 15, and for further kilometers traveled it is 8 rupees per kilometer. So we have to check whether this forms an arithmetic progression or not, and if it forms arithmetic progression, we have to give the reason why, and if it does not form, then also we have to give the reason why. So as they have given taxi fare for the first kilometer, which is nothing but rupees 15, and for additional kilometers the taxi fare is rupees 8 per kilometer. Okay, so now the data has been written in the mathematical form. Now we have to write it in a more simplified way. So for 1 kilometer the taxi fare is rupees 15, and now for 2 kilometers, so rupees 15, and we know that for the additional kilometer it is rupees 8 per kilometer. So 15 plus 8, which is nothing but equals to 23. For 3 kilometers, again we have to add 8 to the previous amount, that is rupees 23 plus 8, which is nothing but 31. And for 4 kilometers, it is 31 plus 8, which is equals to nothing but 39. So, and this goes on. So the series formed here, so you should not write the AP formed here. Why? Because we don't know yet is it an arithmetic progression or not, so you have to use the word series. The series formed here is given by, so for the first kilometer it is 15, for 2 kilometers it is 23, for the 3 kilometers it is 31, and for the 4 kilometers it is 39, and it goes on. So this is the particular series what we have occurred. So here we know that the first term A, which is nothing but 15, and let us check what is the common difference. That is nothing but second term minus first term. D is equals to 23 minus 15, which is equals to 8. And similarly we can check for the other terms. 31 minus 23, which is nothing but 8. Again 39 minus 31, which is nothing but 8. So we are getting the common difference as 8, and we have the first term as 15. So is this forms an AP? Yes, of course. Why? Because we have the first term and the common difference in all the terms is nothing but 8, and hence this series forms an arithmetic progression. So this is how you check the given situation forms an arithmetic progression or not. So I hope this problem about this taxi fare is clear. So moving on to the next problem. So moving on to the next problem, that is the amount of money in an account every year when rupees 10,000 is deposited at compound interest at 8% per annum. So an amount of rupees 10,000 is deposited in a bank which gives an interest of 8% per year, that is per annum. It means per year it will give 8% annum, that is it is not on the basis of simple interest, it is based on compound interest, and hence we have to check whether for the years coming ahead whether this forms an arithmetic progression or not. For the first year what will be the amount, and for the second year what will be the amount, for the third year what will be the amount, and so on. We have to calculate, and after that we have to check whether this forms an arithmetic progression or not. So since it is a problem on compound interest, and we know that the compound interest is given by the formula P into 1 plus R divided by 100 whole raised to n, where P is the principal amount, R is the rate of interest, and n is the number of years. So now we shall write down whatever the data that which has been given. So the amount, that is the principal amount, which is rupees 10,000, principal amount deposited, which is nothing but rupees 10,000, right? And after that they have given the rate of interest, that is nothing but rate of interest, that is nothing but R, which is equals to 8% per annum per year. Okay, per annum is nothing but per year. So we have to now calculate the compound interest for 1 year, and after that compound interest for 2 years, and compound interest for 3 years, compound interest for 4 years, and so on. So we will be using some common sense here. Okay, just for we will calculate for the first year. For the first year, amount is given by P into 1 plus R divided by 100 whole raised to n, that is, so we know that the principal amount is 10,000 into 1 plus 8 divided by 100 whole raised to 1. Why? Because the number of years, so we are just calculating for the first year, hence n is equals to 1. So this becomes 10,000 and 1 plus 8 divided by 100. So this is for the first year. So again, if you calculate, you need not simplify this. So for the second year, you need not again write all these things. So instead of 1, you will be having 2 here, right? So the amount will be, for the second year, the amount will be 10,000 into 1 plus 8 divided by 100, the whole square, right? And for the third year, amount will be 10,000 into 1 plus 8 by 100 whole cube, and so on. It goes on, right? So the thing you have to use here is your common sense. So just if you simplify this, you'll get some value, right? So just observe, here we have 1 plus 8 divided by 100, and you'll be getting some value here. So since 1 plus 8 divided by 100, you have whole square here. So obviously you will be getting a larger amount here from here, right? So you'll be getting a larger amount in the second year than the first year. And obviously in the third year you'll be getting much more bigger amount than the second year, right? So the series will be 10,000 into 1 plus 8 divided by 100, comma 10,000 to 1 plus 8 divided by 100 whole square, comma 10,000 into 1 plus 8 divided by 100 whole cube, comma, and so on. So obviously it is increasing year by year, right? So from the first year it is increasing, to the second year, and third year you are getting a much more bigger amount. So if you observe, there is no common difference here. So if you minus this value, if you calculate this value and this value, and if you subtract these, you will get some value, right? You will get some value, and if you subtract this from this, you will be getting a different value, and these two values will be different. Why? Because each year you will be getting a much more higher amount than the previous year, and hence the common difference of these two terms is not the same, and hence we conclude that this particular series does not form an arithmetic progression. So you have to write the reason. Since the series does not have a common difference, and hence we conclude it is not an arithmetic progression. So I hope this problem is clear. That is, so if you have any doubts, you can calculate this. You can calculate these three terms and just subtract the second term from the first term and subtract the third term from the second term. You will be getting two different common differences. You will be getting two different values, and hence you can verify that it does not have a common difference, and hence it is not forming an arithmetic progression. So these were some examples related to the situation, and now we will be solving some more simple problems related to the arithmetic progression. So the next kind of problem is, so they will be giving you the values of a and d, so you have to write the first four terms of the arithmetic progression. So for the first problem, they have given the values of a and d, so you have to write the first four terms of the arithmetic progression. So you can use the general form of arithmetic progression. By general form of arithmetic progression, so we know that the general form of arithmetic progression is given by a plus d, a plus 2d, a plus 3d, and so on. So since we need the first four terms, I am just writing the first four terms of the generalized form of AP. So as we know that a is equals to minus 2. So minus 2 plus d is 0. Minus 2 plus 2 into 0, comma, minus 2 plus 3 into 0, and so on. So this implies minus 2, comma, minus 2 plus 0 is minus 2, and again 2 into 0 is 0, minus 2 plus 0 is again minus 2, and minus 3 into 0 is 0, minus 2 plus 0 is again minus 2. So these are the, and so on, this continues. So these are the first 4 terms of the arithmetic progression. So how do you verify whether you have done the problem correct or not? Just see the first term, a is equals to minus 2, so we had a is equals to minus 2, and again subtract the second term from the first term, d is equals to minus 2 minus of minus 2. So d is equals to minus 2, minus into minus is plus, minus 2 plus 2 gets cancelled, so d is equals to 0. So hence we got d is equals to 0 and a is equals to minus 2. So whatever we had written here, that is the first 4 terms are right. So coming to the next one, so a is equals to 4 is equals to 4, d is equals to minus 3. So again, by the general form of AP, we know that by the general form of AP, a comma a plus d comma a plus 2d comma a plus 3d and so on. So we know that the value of a is 4, 4 plus of minus 3 comma 4 plus 2 into minus 3, 4 plus of 3 into minus 3 and so on. So 4 as it is, 4 plus of minus is minus, 4 minus 3 is 1. Now 2 into minus 3 is minus 6, 4 minus 6 is minus 2, and again 3 into minus 3 is minus 9, 4 minus 9 is minus 5 and so on. So again you can verify a is equals to 4, we got a is equals to 4, and just subtract the second term from the first term, 1 minus 4, which is nothing but minus 3. So hence we got the second term as well, which is minus 3. So I hope these problems were clear. So moving on to the next part. So in this part they will be giving you an arithmetic progression. You have to check if they form an arithmetic progression, and if they form an arithmetic progression, you have to write the next 3 terms and also find the common difference of that particular arithmetic progression. So for the first example, I have taken 2, 4, 2, 4, 8, 6, 9, so on. So we shall check whether this forms an arithmetic progression or not. So given 2, 4, 8, 16 and so on. So here the value of a is 2, and now we can check the common difference. So d is equals to a2 minus a1, which is nothing but 4 minus 2, which is nothing but 2. Again we can check it for the third and second term, that is a3 minus a2, that is 8 minus 4, which is nothing but 4. And again for the fourth term, that is a4 minus a3. So the common difference for the fourth term minus third term, that is given by 16 minus 8, which is nothing but 8. So if you observe here, we have got 3 different common, so here we have got 3 different differences. So we have nothing in common, and hence we conclude that it is not an arithmetic progression. So we have to write the reason first, that is, since there is no common difference in the given series, we conclude it is not an arithmetic progression. And if we had got a common difference, we would have concluded it as an arithmetic progression, and further we would have written the further 3 terms of this particular arithmetic progression. And since we did not get a common value as the common difference, hence we conclude that it is not an arithmetic progression. So coming to the second problem, that is 3, 3 plus root 2, 3, 2 root 2, 3, 3 root 2 and so on. So we will write down whatever they are given again. Given 3, 3 plus root 2, 3 plus 2 root 2, 3 plus 3 root 2, and so on. So here we know that the first term a is given by 3, and then now again we can check for the common difference, that is d is equals to a2 minus a1, which is given by 3 plus root 2 minus 3. So 3 gets cancelled and we are remaining with root 2. Again we can check for the third and second terms, a3 minus a2, which is given by 3 plus 2 root 2 minus 3 plus root 2. So again 3 plus 2 root 2 as it is. So minus multiply to the bracket, minus 3 minus into plus minus root 2. So again plus 3 and minus 3 gets cancelled and we are remaining with 2 root 2 minus root 2. So since root 2 and root 2 is common, we can take root 2 as common. We are left with 2 minus 1, which is nothing but 1 into root 2, which is nothing but root 2. Now we got the same value as the common difference. Even you can check for the last two terms, that is a4 minus a3. So 3 plus 3 root 2 minus 3 plus 2 root 2. So again you will be getting root 2 as the value. So hence we conclude that we have a first term, that is a is equals to 3, and we have a common difference, that is root 2 in every cases. And hence we conclude that since the values of a and d are absolute, it means they are 2 absolute for the given series, we conclude that it is an arithmetic progression. So the problem does not end here. So they have given that if they form an AP, find the common difference and write the 3 more terms. As we have now found the common difference, so the common difference is given by d is given by root 2, and now again we should find the 3 more terms. So since they have given a plus d, a plus 2d, a plus 3d, so they have given the first 4 terms. Now we should write the 5th term, 6th term, and the 7th term. So we should find a plus 4d, a plus 5d, and a plus 6d. Right? Next terms, next 3 terms are a plus 4d, a plus 5d, and a plus 6d. Just substitute the values of a and d and you will be getting the answers. So the value of a is 3. So in the place of a, I am writing 3 plus 4 into the common difference we have found, that is root 2, comma, and a plus, that is 3 plus 5 root 2, comma 3 plus 6 root 2, and so on. So just summing this up with the given series, that is the whole series becomes so just first write the first 4 terms, that is 3 plus root 2, comma 3 plus 2 root 2, comma 3 plus 3 root 2. So now we have found the next 3 terms, that is 3 plus 4 root 2, comma 3 plus 5 root 2, comma 3 plus 6 root 2, and so on. So these are the next 3 terms which we have found out. So this was all about today's class. In today's class we started with the problem, that is if we are given a situation, we are finding the mathematical form of that situation, and after that we are checking the it forms an arithmetic progression, and if it forms an arithmetic progression we have given reason, and if it does not form an arithmetic progression then also we have given reason. And after that we solved some problems related to the values of a and d. When the values of a and d are given, you have to write the arithmetic progression. And after that lastly we studied about the how to check whether the given series is an arithmetic progression, and if it is an arithmetic progression, writing the further terms we have learnt in this class. So if you have any queries related to today's class, you can contact me. And we have to complete the exercise 5.1, and after that we will be moving on to the next part of the arithmetic progression. Thank you.